All right, welcome back to another video. Today we're going to take a look at the OCR GCSE paper J249 from Wednesday, May 2018. So I'm going to go ahead and answer the first multiple choice questions. I'm going to start with question number 1. What is the gravitational field strength at the Earth's surface? That's pretty simple. A, that's just a rounded up version, 10 newtons per kilogram. What is the voltage? What voltage is the maximum voltage when four 1.5 volts are connected in series? When four things are connected in series, like bulbs, you can add their voltages. So the total voltage here is just going to be 1.5 plus 1.5 plus 1.5, blah, blah, blah. And we know that if you add four 1.5s, you get 6 volts. So the answer is D. Keep in mind, however, that when a couple of components are in series, the total voltage they have is going to be the same. So they all have the same voltage, but they have the same current, but different voltages. Now, let's take a look at question number 3. Cog X has 16 teeth and Cog Y has 8 teeth. Cog X has turned around 2 times. How many times does Cog Y turn around? Now, if you divide 16 by 8, you'll find out the number of turns that Cog Y does, each time that Cog X turns. So we're going to get 2 turns. And because it's actually turning 2 times, 2 times 2 is 4, so the answer is C. That means that for each turn that X does, Cog Y does 2 turns, and since it's doing 2 turns, then Cog Y should do 4 turns. What is the smallest number of forces needed to bend an object? In order to bend an object, you need about 2 forces, one pulling it from one direction, the other pulling it from the other direction. So the answer is B. The diagram below shows the relationship between force and extension for a spring. Which letter on the graph shows the elastic limit of the spring that is being stretched? The elastic limit is reached at point C. That is when you start to have plastic behavior because the spring no longer returns to its original position. As if you didn't know, elastic limit is the point where too much force is applied to that spring, and as a result, it does not return to its original position. So the answer is C. This is a circuit. Which letter A, B, or C, and D shows the part of the circuit that carries a current of 2 amperes. Obviously, as you can see, if you consider this to be the 2 ampere is going to go through that resistor, and then it's eventually going to come out of it, right? So part D is the part which has a current of 2 amperes. Question number 7 says that a student has 3 identical resistors. She arranges them in 4 different ways. Which arrangement has the most resistance? For this one, you can actually kind of come up with, you can give the resistors a value and find out which one has the most, but you don't really have to do it because whenever, 3 resistors are in series, or anytime they're in series, they're going to have the highest amount of resistance because the amount of total resistance in series is always going to get added. So if this is R1 and this is R2 and this is R3, R1 gets added to the value of R2 plus the value of R3. So if I were to give them values, this would be 10, this would be 20, and this, let's say, be 30. 10 plus 20 plus 30 would give us a value of about 60 ohms, right? So if you were to also give the same values for the other ones, you'll see that all of them would have less resistance than B. So the answer would be B. And that's because, for example, in the first one, they're in parallel. And whenever you want to find out the sum of resistances in a parallel circuit, you would have to find the sum of the reciprocal of the fractions of the resistant value. So you have to do 1 over 10 plus 1 over 20 and 1 over 30 if they were in, for example, parallel with each other. I'm talking about, for example, case A, if this was 10 ohms, this was 20 ohms, and this was 30 ohms. And in that scenario, you would get a small value of somewhere around 5.45 ohms, which is much less than case B. Let's take a look at question number 8. This is a really simple question because it gives you the formula. It says, what is the speed of the object? It travels 800 meters in 40 seconds. So obviously, you just have to find out the speed of the object. Now, you have to rearrange the formula. Speed is going to be distance divided by time. So you just have to divide 800 by 40. The zeros cancel out, and if you divide 80 by 40, you're just going to get 20 meters per second, which is choice B. Now let's go ahead and take a look at question number 9. It says an object is moved 20 centimeters with a force of 20 newtons. What is the correct calculation of the work done? So if you want to find out the work done, all you have to do is just multiply the force by the amount of distance, right? However, keep in mind the distance is given in centimeters, so you have to convert this into meters. We know that 100 centimeters is equal to 1 meter, so 20 centimeters is 0.2 meters. So the work done is going to be the force, that is 20 newtons, multiplied by the amount of distance, which is 0.2 meters. Now 20 times 0.2 would give us a value of 4 joules, which is choice B. In which situation does a force cause a rotation? Bouncing on a trampoline, no, that's just going to cause, an up and down movement. Hitting a nail with a hammer, again, no, that's just going to push the nail into the, wall or whatever you're trying to put the nail in. Pushing a friend on a swing, that is going to cause a rotational movement. And sitting on a chair is obviously not going to create a rotation. So the answer is C. Which one is scalar? Obviously, we know that there's two types of quantities, scalar and vectors. I have tons of videos about that on my channel. Make sure you go and see them. And so obviously the answer is not A, acceleration. Displacement is not correct. Force is not the one. And D, the speed would be the correct answer. All the other ones are actually vector quantities. These statements about pressure and volume of a gas. Okay, so we know that pressure is indirectly proportional to volume. That means if you kind of increase pressure, then volume goes down. So if volume doubles, pressure does not double. If volume doubles, pressure halves. Well, that seems to be correct so far. If volume halves, pressure halves, no, they have no direct relationship. They have an indirect relationship. And no, if volume changes, pressure does change. So the answer is actually B. If volume doubles, pressure halves. Which of the following has the most kinetic energy? The highest amount of kinetic energy is dependent on the mass and the speed of the object. So you can calculate the kinetic energy of each one of these by using the formula 1/2 of mv squared. But because I want to, cut up the amount of time for the calculation, I'm just going to calculate the one that I think is the correct answer, which is C. So I just have to multiply 1/2 by the speed of this elephant, which is 4 to the power of 2, by the mass that it has, which is 3,000. And you'll find out that this one, if you multiply all those numbers, actually has the highest kinetic energy. So C is the correct answer. Which distances are the same? So in order to find out which distances are actually the same, you have to convert the scientific units into normal scientific notations. So for example here, 1 times 10 to the power of -3 is 1 millimeter, and then this is 1 micrometer. A micro stands for 10 to the power of -6. The next one, 10 to the power of -6, is a micro, so it's actually getting, it's saying, is it equal to 1 millimeter? That's not correct, because 1 millimeter is 10 to the power of -3. So those are off. And then the next one, 1 times 10 to the power of -9 and 1 nanometer. NM stands for 1 nanometer. And 1 nanometer is actually 1 times 10 to the power of -9. So that is correct. So C is the correct answer. I'm not going to check D. Now, let's take a look at question number 15. It says, a student studies how the temperature falls when the liquid cools. Obviously, the temperature is going to fall. And they're saying, what is point X on the graph? Whenever the temperature stays constant and doesn't change, you can consider that to be a point where we have a phase change. For example, it's changing from, it's going from solid to liquid to gas. And so since right now the liquid is cooling, we don't have boiling, because that's when liquid changes into gas. How can something be cooling and then, turns into a gaseous form? We don't have melting, and we don't have subliming here either. So the only correct answer is actually freezing, because the liquid is cooling, and so it's kind of getting into solid form, and that's why we have a constant temperature, because there is a phase change. We're going to look at section B in another video, part 2 of the video. Make sure you stay tuned. Help us out by subscribing and liking this video.